welcome back to another episode of Measurement in a Minute. I'm your host, 𝗦𝗧𝗔𝗬𝗓 with Lakeside Process Controls. And in today's episode, we're continuing our discussion around Rosemounta's 3051 pressure transmitter. Now, the last few episodes, we talked about how both absolute and gauge pressure transmitters work. Today, we're going to talk about how differential pressure transmitters work. Now, differential pressure transmitters operate using a different technology, and this technology is known as a capacitance technology. For anybody who's familiar with this technology, you'll know that there's a relationship between changes in pressure and changes in capacitance within a capacitor. And so for that reason, we set up a capacitor when we build out a differential pressure transmitter. So the capacitor is in essence two conductive parallel plates with a dielectric material or a fill fluid in between one another. And as you have a change in distance from these plates, you have a change in capacitance. And that's exactly what we do here. So we fix one of these plates and we allow the other plate to flex. So in this case, if we apply pressure to it and that distance is reduced, you see in the equation above me, if that bottom denominator term D gets smaller, well, the resulting capacitance is going to increase. And that's directly measured and correlated into pressure. But keep in mind, this is only going to give us pressure, not differential pressure. So how do we get differential pressure? Well, we actually use two capacitors side by side, and they share a middle common plate that is allowed to flex both ways. And so what this does is it creates what I like to call a tug of war between the high side and the low side. And we call it this way because the high side is going to be exposed to a higher pressure and the low side is going to be exposed to a lower pressure. And so, spoiler alert, we know who wins that tug of war. It's the high side. But what this does is it allows us to apply physically the pressure from the higher side of the process. Let's say it's a differential pressure transmitter measuring flow, so maybe before the primary element and then after the primary element. And then we're going to see who wins this tug of war and by how much. Now keep in mind, there's no math here. Okay, it's actually a resulting difference in this flexure that is measured, converted into a change in capacitance, converted into a differential pressure. So if I give you an example to understand this, if we had 300 bar applied to the high side, 5 bar applied to the low side, it's going to see 295 bar of flexure. So it's not going to be doing any math here, and that's very important to understand. We are physically opposing with 300 bar and 5 bar. They're fighting against each other. Like I say, it's kind of like a tug of war, but maybe in the opposite direction. And the resulting flexure looks like 295 bar of capacitance change, and that's what you'll get as the output from the pressure transmitter. And that's how differential pressure transmitters work. Should you have any questions about Rosemounta's 3051 or any other of our technologies, please reach out using the QR code on screen. Thanks everybody. Have a great day.